Okay, so I figured out, I think, how to share my screen without having that black bar on the side where I'm not showing my video, so just the screen. And we're going to continue our discussion on design requirements with two final topics, spacing and cover and deflections. Okay. In general, what you need to do is have a cover of 1.5 inches and a spacing of 1 bar diameter or 1 inch. And let me explain what that is. So if you have a beam like this, I wonder if I can draw a rectangle and then make it automatically. Oh, that's pretty good. Let me try that again. So I think I can draw a rectangle, and if I pause, it'll come out perfect. Oh, there we go. So let me do that from now on. Okay, so here we go. So if you have a beam like that, oh, watch this. I'll bet I can do circles. Oh, nice. Okay, so and then you'll have, I'm not gonna wait for this. So, and you have the stirrup like that. Okay. This distance between the concrete and the steel is called the cover. And for beams that are inside, protected from weather, you have to have at least 1.5 inches of concrete between the air and the steel to prevent corrosion. This distance, the clear distance here, is the spacing. And that has to be 1 bar diameter or 1 inch. Okay, so now, my personal opinion on this spacing. I did an experiment once where I varied that to see if concrete could go through. And I found that that needs to be 2 times the diameter of the aggregate. Otherwise, the aggregate gets stuck. It won't go through. And so if you have a 3/4 inch aggregate, that's 1.5 inches. So I personally think it should be, for 3/4 inch aggregate, the bar of diameter or 1.5 inches, not 1 inch. That's just my 2 cents. Okay, so that's the cover. Now, often in class, I want to talk about this. We've just glossed over it. I've told you that the distance to the centroid of the steel, so let's see, you have just 1 layer of steel, is h minus 2.5 inches. So if the overall height of your beam is h, I'm saying the distance to the steel is 2.5 inches less. Where does that come from? Okay, so this here is a stirrup. It goes around the steel, and that's usually a number 3 or number 4 bar. Let's say number 4 bar. So that diameter there is going to be 4/8 of an inch or 1/2 inch. Okay. We just said the cover from the concrete to the steel is 1.5 inches, and that bar could be anything. Let's say a number 8 bar, because it's easy. The diameter is 1 inch, 8/8, and so to the center of that, or to the radius is 1/2 inch. So this distance here from the bottom to the center of the steel is the 1.5 inch cover, the 1/2 inch stirrup, and the 1/2 inch radius. And if you add that all up, it comes to 2.5 inches. That's where I get D is H minus 2.5 inches. It's obviously approximate, and you could recalculate it if you want, if you put in the actual diameters of what you're using. So the question I have for you now is, what if you can't fit all your steel and you have 2 equal layers like that? And so you can see that the center of the steel is right there now. Okay. And that's your new D. So in that case, you would have, let's say, a bar here and a bar here. And we now want to get the distance. We now want to get the distance to there, okay, to the middle of those um, the two bars. Okay, oops. Let's see if I can move this over. Oh, cut, paste it. Oh, I'm just gonna draw a new one. So here. Okay, so we want to get the distance to the center of those bars. This spacing, we just said, right here, that was 1 inch. And so really, I guess it should be 1.5 inches is what I'm saying. But if it's 1 inch, this total distance here is the 1.5 inch cover, the 1/2 inch stirrup, the 1 inch gap, and the 1/2 inch radius, the 1 inch diameter, and 1/2 inch gap. Okay, so 1.5, 1/2, 1, and then that's another 1/2 inch. And so that adds up to 3.5 inches. And so D equals H minus 3.5 inches if you have 2 layers of steel, 2.5 inches if you have 1 layer of steel. And so finally, let's talk about deflections. You have to calculate the deflections, okay? And we will go over how to calculate these deflections later. It's kind of complicated for reinforced concrete. But if your beam is not supporting anything that can be damaged by deflections, and so deflections aren't super crucial, and if your beam has a minimum depth as given in this table, 9.3.1.1 in the 2019 code, page 129, you don't have to calculate deflections. And these are in span to depth ratios flipped over. So for example, simply supported beam has to be L/16 in depth. Okay, so that's this right here. The H, the overall H has to be greater than or equal to L/16. If you flip that around for L divided by H, that's the span to depth ratio. The span to depth has to be less than 16. There you go. But we will learn how to calculate the deflections, but this is handy if you have a deep beam, and then you don't have to check the deflections, only if it's not supporting something that's easily damaged. So if you have glass partitions or even sheetrock can be damaged by deflections. So typically you will calculate the deflections, and we'll learn how to do that later. Okay, so those are the flexural requirements. Now next we'll actually talk about how to do the design.